Hey guys, it's time for us to start talking about LLDP. Now, LLDP maybe seems strange because LLDP isn't a Cisco proprietary protocol like CDP, but we also have to face the fact that there are people out there that have poor decision-making skills. Now, that means they've acquired devices that weren't manufactured by Cisco. Now, Cisco obviously wants to work and play well with as many different vendor manufactured devices as humanly possible. And since the industry standard looked at CDP and said, that is cool, and they stole their own version and created it called LLDP, Link Layer Discovery Protocol, we need to spend some time talking about how Cisco embraces the solution and how we need to recognize the fact that our devices are going to support the idea of LLDP. Now, in the confines of LLDP, it's important for us to keep in mind that, like I said, it's not a Cisco proprietary protocol. It's an industry standards body defined protocol, but it still does pretty much the exact same thing that CDP does it differently. CDP and LLDP are not compatible with each other, but our devices do have the capability of running both LLDP and CDP. Now, let's take a look at what's going on with regard to our theory, and then what we'll do is we'll move directly into our conversations about configuration, and then we'll take a look at some diagnostics, just like we did in the confines of CDP. Now, the whole purpose of embracing LLDP was so that Cisco devices could interoperate with other vendor manufactured components. That includes telephones, includes a number of other devices, wireless access points, and different hardware configurations and different hardware variables. Now, what we have to recognize is in order to be able to do that, Cisco had to come along and say, well, we have CDP, Cisco Discovery Protocol, and the industry standards body created their own protocol called LLDP, Link Layer Discovery Protocol. Now, Link Layer Discovery Protocol is actually, since it's an IEEE standards body designed, it's actually assigned its own value, and that's going to be referred to as 802.1ab. That is going to be, just like 802.1p, the value that you're going to have that's going to define all of our Link Layer Discovery Protocol operational parameters, timers, values, and guess what? TLVs. Because again, that idea of being able to have that variable payload, the industry bought into that hook, line, and sinker and realized just how extensible and how expandable that makes a protocol. So in the confines of LLDP, they support the same configuration the same way, but they do it slightly differently. Now, just like CDP, LLDP is designed as a protocol that's going to support this concept of neighbor discovery. Now, I'm not going to go through and create discovery. I'm not going to go through and create a configuration like I did and do all of the mapping, but we will exercise all of the commands that we need to know to work with LLDP. And there's not a lot, and it's so similar to CDP, we're not going to spend anywhere near as much time on LLDP as we did with regard to CDP. But what the main thing here is again, it's a layer 2 protocol that allows me to make neighbor discovery information and exchange information related to capabilities of my neighbor and of my link, and record information even though I may be operating or using devices with different layer 3 routing protocols. So again, it's pretty much the exact same thing that we had when we were talking about CDP, but remember, it does things differently. Now, the whole concept is it does it differently, i.e. we have different fields and different placements, but it still accomplishes it in pretty much the same way. And by that, what am I making reference to? Well, I'm making reference to the fact that we use these TLVs, these type linked values, so we can have those variable payloads, so that we can have all of the communications that we have with CDP only in an IEEE industry standards protocol. Now remember, like I said, CDP and LLDP are not compatible with each other. I can't have CDP on one link and LLDP and exchange information between the two protocols on the other. So we have to either run both or just pick one and use it on that link. Now, since everything is going to be configured more often than not on a link-by-link basis, what we do find ourselves looking at the situation where we can actually be selective as to where we do the configurations. Again, keep in mind, LLDP is going to maintain stateful information about the associations in a table. It's not called a CDP table, it's called an LLDP table. Now we need to look at that. And again, the information that we're going to exchange, we'll see when we look at the diagnostics component of our discussion, we're going to recognize very quickly it does the exact same thing that CDP does, and it's going to exchange information not about just our neighbors, but about our neighbors' capabilities and compatibilities so that we can best choose a way to interoperate with those devices. Now, the TLVs come to us and they're used, but what I want to point out here is like I said, we have different values that we want to make certain that we realize we need to embrace. We have this idea of port description, system name, system description, system capabilities, management addresses, as well as our MAC or physical address information that we need to be able to exchange based on another industry standard tool, 802.3. 802.3 being the bounding configuration inside of IEEE that defines Ethernet and Ethernet operation. Now, when we look at how the devices are set up and configured, again, we want to recognize the fact that we're exchanging this information and we're exchanging it in such a fashion that we're going to be able to learn everything we need to know about our neighbors. Now, we have timers, just like we had in CDP, and here's an example of the timers that we have to work with. Let's just walk through them very quickly, and then we'll go into the demonstration. So looking at this, we see that we have something referred to as the LLDP global state. Now, that global state is going to be disabled on Cisco devices by default. We have this hold down timer. Same operational definition as we had with regard to the hold down timer in CDP. If we do not receive a hello in that period of time, we're going to actually expire the entry that we have for that neighbor from our LLDP table. Now, other elements that we have here are going to be the frequency. Notice this, the timer here is going to be 30 seconds, and the hold down time is a value of 4 times that particular calculation. So if I miss 4 subsequent hellos at 30 seconds rather than 60, what I'm going to end up doing is I'm going to expire that link. Other things that we have here that we don't have in the confines of CDP is this idea of a reinitialization delay. A reinitialization delay is going to be a value of time, measured in seconds, that we're going to wait before we try to send messages out on a link. The idea is the industry standards body picked a 30-second timer for their hello messages, but they decided to integrate this reinitialization delay in order to give time for the layer 3 protocols and any running IGPs that we may have in our infrastructure time to converge before we try to start exchanging information that's going to involve layer 3 info. Remember, it's still a layer 2 protocol. So whether the IGP is converged is irrelevant for the purposes of identifying our link, but if we want to exchange information about states and capabilities or mismatched information with regard to config, we want to also sometimes make certain that those protocols have had time to converge. We can select TLVs that we want to be able to use. Just like we did in CDP, we're going to find that we have more that we can choose from inside of LLDP than in CDP, but we're going to discover that in the configuration discussion. We can modify the interface state. We can select whether or not we want to individually transmit and receive LLDP information on an interface by interface basis. And then the other thing here is that we have this idea of the med-TLV select. That's not going to be a feature that we're going to need to understand or deal with. It's going to be something that principally runs in the confines of like a 4500 series Catalyst device rather than the 3750s that we have inside the context of or the 3560s, excuse me, that we have in the context of the CCIE Routing and Switching version 5 exam. Now, what we've done is we've talked about the comparisons. Now it's time to dive into the equipment and just show how simple it is to configure LLDP, look at some show commands, and then what I want to do is I want to analyze some of the packet information. So again, you guys have an idea of what this layer 2 protocol looks like in the confines of packet capture or in Wireshark or embedded packet capture. So I'll see you guys in that video. Bye-bye.